just as equations can be solved numerically and graphically, so can inequalities. It's just that the process is a little bit more complicated. It's not as mindless a process as, as solving equations is, right? So suppose we want to solve this inequality here. 14 is greater than negative 3.5x. We want to solve this graphically and numerically. Well, what do we do? Right? So we'll start with the tables, right? Solving numerically. Well, pretty much always what you're going to do whenever you're solving numerically or graphically, whether it's an equation or inequality, is you're going to use your graphing calculator and make one side of the equation or inequality your y1 and the other side be your y2. So that's what we have here, right? y1 equals 14 and y2 equals negative 3.5x. All right? So then we're going to inspect the table, and the first thing we're going to want to really do is find out where the two are equal to each other. And we can see right here at negative 4, they're both equal to 14. So if this was an equation that we were solving, we'd be done. The answer would just be x equals negative 4. Simple enough, right? But this is an inequality. So what we're trying to do is we're trying to find where, right, in what interval 14 is greater than negative 3.5x. Well, this column is always 14, and this column here is always negative 3.5x. So we want this column, the y1 column, to be bigger than the y2 column. So just look at each row and see where that is true, right? So here at negative 6, 14 is not greater than 21, so it's not true there. Here, 14 is not greater than 17.5, so it's not true there. Here, we already found it's where they're equal, so that's kind of like our switching point. And then everywhere below this, right, 14 is greater than 10.5, 14 is greater than 7, 14 is greater than 2.5, greater than 0, and greater than negative 3.5. So over here, it's always true. So negative 4 is like the switching point, and everywhere greater than negative 4, right, negative 3, negative 2, negative 1, 0, and 1, it's always true. So the solution to this inequality would be all the numbers that are greater than negative 4. Now just realize if this was 14 is greater than or equal to negative 3.5x, then this row here would also be included, and then it would be x is greater than or equal to negative 4. But since it's strictly greater than, we don't include the negative 4. Right? So that's the only difference there, if it was greater than or equal to versus greater than. Right? And then from the graph, we do the similar thing. Right? We first would just see where, all right, well, here's our line, y equals 14. Right? So this is like our y1. y1 equals 14. And this line here, this diagonal line, this is our y2, which is negative 3.5x. So we want to see where y1 is greater than y2. And graphically, greater than means above, right? So in terms of a graph, greater than means above. So we want to see where y1 is above y2. Well, over here it is, right? This is the area where it's above, and this is the area where it's below, right? And where does it change? It changes right here at negative 4. So we can see that y1 is above y2 everywhere to the right of negative 4. And again, what does to the right of mean? It means greater than. So everywhere where x is greater than negative 4, y1 is greater than y2, meaning above. Right? So that's something to remember when you're solving graphically. Greater than means above, and less than would mean below. Right? So if it's greater than, you're looking for it to be above. If it's less than, you're looking for it to be below. Okay?